Okay, let's solve a real life problem that involved rate of change. So what we have, the trough is 12 feet long. So 12 feet long, I write down right away, L is equal 12 feet. And 3 feet across the top. So three feet. Its ends are isosceles triangles with attitude of 3 feet. Okay, it's gonna be h is equal 3 feet. All right. So, A, water is being pumped into trough at 2 feet cube per minute. So when we say with the rate of 2 feet cubed per minute, that's the rate of change, right? 2 cubic feet per minute. And rate of change of what? Because we have cube, right? Cubic at the cubic feet, then it's gonna be volume, because volume is the one is measured in cubic. There we go. Here it is on the picture. So it's gonna be either V prime. Okay, V prime is equal to cubic feet per minute, the rate of change. How fast water level will rise? When it says how fast, it's also asking a rate of change. Where rate of change, it's a first derivative again, right? How fast is the water level rising in the depth, with the depth? Okay, let me just fix it. With the depth h is 1 foot. Okay, I was dictating, Siri was typing and didn't pay attention. Okay, I'll put right down. So, how fast is the water level is rising with the depth h is 1 feet. Now, here is the thing. When we say the water level is rising, that's the speed, right? It's moving higher and higher and higher. That not speed. That's the height, right? Changing, correct? So we need to find h prime. And the level rising with the depth when h is equal, at the h is equal 1. Okay? All right. So, what do we have? We know that the trough is the right triangular prism. Here it is. I put it here. This means that the volume is the area of the triangle, is the area of the triangle 1/2 b times h, and multiplied by length. Okay? Between two ends. So what do we have at this point? We have 1/2. We know h is 3. B as a base is 3. And times 12, it's equal 54 cubic feet. That's entire volume. You can fill up with in the prism. Okay? maximum at 54 cubic feet. All right, but we don't need to know the maximum, the full, the prism full of water. All we want to know how fast the water will be rising. So change of rate for the height, knowing change of rate for the volume. Okay. So like I said, we don't need to know the volume of the trough, but we need to know the volume of the water in the trough as a function of height. Yeah, because height will be changing. So as you can see based on picture, as the water fill up the form, the water forms its own right triangle prism, right? If we fill up like this, it's filling its own right triangular prism. Therefore, the volume is also will be identified based on this formula. Okay? But this time the height is variable h, not the h statistical value of h, but variable, and it's meaning change of h, and that depends of time, because as you fill up the water, its h is changing upon time. So how about the base of the triangulars ends B? Because the triangular end of the water filled by the water is similar to the triangular end of the trough, we can see that they share the same ratio, because the ratio of B to H is 3 to 3, which is 1 to 1, right? So then that means that the ratio is going to hold for the water as well. Therefore, that means we are going to have V, it's going to be equal for the water 1/2 times H, and because it's 1 to 1, I'm going to replace base with the height and be multiplied by 12, and it's going to be equal 6h squared. 6h squared. Okay. Now, when we are filling up water, it's the volume and the height is changing based on as time goes, right? So, which means end V, volume, is a function of T, and H is a function of T. Therefore, I can write down the change of the V, it's going to be V of T, because it's a function of T. I can write down 6 times H of T squared. Okay? All right. So, well, we need to find a change of height, correct? How fast, it says, how fast the water is being pumped into a trough at 2 cubic feet per minute. I mean, yeah, water level will be rising with the depth h. Okay, so that means when it says how fast, that right away should click in your mind that we are taking derivative, right? Okay, so let's take a derivative. So what we are going to have, since depends on function, that means we are going to have dv by dt is equal d by dt 6h squared. We write down like that. 6h squared, right? So, and we are going to use chain rule here. So dv by dt is going to be v prime, right? Same way I can write down. Now d by dt for 6h squared, what is going to be? It's going to be equal 6 times, 6 is a constant, derivative of h squared is going to be 2h to degree 1, I don't have to write down, and times derivative of h itself. That depends on t. Yes? Okay, so from here, since we need derivative of h, rate of change of h, how fast the hive is changing, h prime of t is going to be equal d prime of t divided by 6 times 2h, right? Now, v prime, we know it's 2. Here it is, 2 cubic feet per minute. Dividing by 6 times 2, and it's asking at h is equal 1. Here it is. H prime at h is equal 1. So h is going to be equal 1. So that is equal 2 over 12, and that is equal 1/6 feet per minute. Okay? We don't have here feet cubed because we are finding change of hive. How fast the water, the hive will change as the water pumped in. All right? So this is answer for A. Let's move to B now. Moving to B. The water is rising at the rate of 3/8 inch per minute. So, water is rising, that's the hive, right? Okay. It's gonna be h prime or dh by dt, right? Or h prime. 2, how much was that? 3/8 inch, yeah. Wow, it's inch, it's not even foot, so we have to do conversion. 3/8 of inch per minute. Okay. When h is equal to, okay, this is at the h is equal to inch, I would say. Doesn't say, okay, is equal to. Determine the rate at which water is being pumped into trough. All right. So, which means the rate it's being pumped into trough. Now, here is asking the change, rate of change of the volume. Okay? Which means we need to find out h prime of t is equal question mark. Okay? Because it's pumping, we need to find out the rate at which the water is being pumped into the trough. All right, so we know that V prime, here it is, the formula. That's a common for both cases, A and B. D prime of t is equal 12h multiplied by h prime of t. Okay. So we have everything to plug in, but one case, one thing. The measurement is in inches. We need to convert into feet. Okay? So why? Because the 12 is also feet. 12 is feet. 3/8 is inch per minute. So either we have to convert feet into inch or inch into feet, since the entire word problem is about feet. So it makes sense to convert inch into feet. Okay, so let's convert. 3/8, excuse me, inch per minute equal 3/8 inch per minute times 1 foot over 12 inches, because 1 foot is 12 inches, right? And that is going to be equal 1 over 32 feet per minute. Okay? Well, once we have it, we can plug the values. So v prime of t at the value of h is equal to is equal. So 12, I'm applying this formula, right? 12 times, my age is 2, right? Here it is, I plugged it here. And h prime, it's going to be 3/8 inch per minute, or 1 over 32 feet per minute. And this is going to be 3/4 cubic feet per minute. And it's done. So how fast it's filling up? It's 3/4 cubic feet per minute. And how the rate of change for the height, it's 1/6 feet per minute as you pour the water in the trough. So here is a nice example of a problem that is used in life, and example of using first derivative. Okay, hopefully it helped. If you have any questions regarding this problem, just ask me away in the comments. Otherwise, if you like it, let me know. Okie dokie, see you in next video.